Okay, here we go. This is lesson 3. Yay, I finally did it. So if you're going to reflect over the x-axis, your y coordinate will change. What I like to say is if you're reflecting over the x stays the same. If it makes you feel better, it makes you remember it better, you can say if you're flipping over the x, the y changes because it's the opposite here. If you're flipping over the y, the x changes. I like to remember what stays the same. So if you're reflecting over the y-axis, the y stays the same. Flip over the x stays the same. Flip over the y stays the same. So down here, we're going to practice that. This column right here is all flipping over the x. So as we go to rewrite each of these points, if we are reflecting over the x-axis, the x stays the same, and that will be -3. 7, -3. If we are flipping over the x stays the same. So that's -10, -4. Even though it's negative, it still stays the same. We're reflecting over the x, so the x stays the same, which means that -13 has to become a +13. And if we're flipping over the x is going to stay -20. The -10 will change to +10. Any questions on that? So you did copy these notes last week, but you couldn't hear sound. So that's why we're redoing it.
I could.
You could. Well, you've got good ears then. Anyone have a question? Okay. This column over here, we're going to reflect over the y. So if we're reflecting over the y stays the same. So that means we have to take the opposite of x. That one's going to be -7, 3. We're flipping over the y. So the x is going to be opposite and the y stays the same. We're flipping over the y. So the x is opposite. The y stays the same. Notice I say it every time. It just helps get it in my brain. All right. So if we're flipping this over the y, the x changes. The y stays the same. Question? Easton, question? No? All right. So anyone else have a question on that first group there? All right. Now we're going to use arrow notation to describe this transformation. You can see that this looks like we folded it over the y-axis, right? It looks like we folded it right here. And you can see that if we count 3 over to the y here, we count 3 to get here. So this is a reflection over the y. So our arrow notation always starts xy, and then we draw an arrow to say what it becomes. And if we're reflecting over the y stays the same. So there's your arrow notation. Okay, so these are notes you can check to make sure yours looks the same. Example 3, the coordinates of a point and its image after a reflection are given. Describe the reflection as over the x or over the y. So I'm going to look to see what's the same. I see, can you just stop, Owen? There's already 2 people out. Can you sit down? Okay. All of a sudden, everyone's getting up and leaving. All right. So my x is -3. Here it's +3. So my x changed. That did not stay the same. But the y was 5. So that tells me this is a reflection over the y-axis. The y stayed the same. Okay. Triangle JKL has these 3 vertices. without graphing. So they don't always want you to be able to draw a graph and count to where your line of reflection is. They want you to know the rule. Find the new coordinates of point J after reflection first over the x-axis and then over the y. So even though they gave you 3 points, they're only focused on one. So let's write the rule first. We're going to take xy and we are going to reflect it over the x-axis, which means that my x is going to stay the same. So this new point is going to be x comma negative y. And then I'm going to reflect it over the y-axis. So now this is my x right here, and this is my y right here, and my y is going to stay the same. So I'm going to negate that x, negative x, and the y stays the same, which is negative y. So now let's take that point, negative 7, 4. Whoops-a-daisies. We're going to take the point, negative 7, 4, and we're going to reflect it over the x. We're going to keep x the same, so that's negative 7. And we're going to negate the y, so that's negative 4. And then we're going to take that point, the negative 7, negative 4. We're going to negate the x. The x is a negative 7, so that's going to be positive 7. And we're going to negate the y. Is that right? I have to think about that for a minute. And then over the y-axis, so the y stays the same. This should be negative 4 right here. The y stays the same. That's an interesting take. So this one, I don't know how that was described in your notes Thursday, but that should look like this one here. That might look different on your last set of notes because it's hard to write that rule. Okay. Suppose you reflect a triangle in quadrant 1 over the y-axis. So I'm going to draw a little quadrant here. Here's triangle in quadrant 1. Remember, quadrant 1 is the top right. And in what quadrant will the image of the triangle be if you're reflecting over the y-axis? So if you're reflecting over the y right here, that's going to end up being in quadrant 2. So if anyone had some questions left over from Thursday, I think that should help.